Each element on the periodic table is represented with its atomic number and its atomic weight. The element's atomic number, represented here by the smaller value, tells us how many protons are present in the nucleus of an atom for any given element. It also tells us the number of electrons for the neutral atom, because in an atom there is no charge, and so the number of protons and electrons are equal. The atomic mass, represented here by the larger decimal value, can tell us how many protons and neutrons are present in the nucleus of an atom for any given element. In a previous lesson, we learned about electron shells and electron configurations. In this lesson, we shall learn about electron configurations of the first 20 elements and how this relates directly to the group and period numbers in the periodic table. Electrons do not simply fly around a nucleus randomly. Instead, they occupy specific levels called electron shells. Each electron shell can only hold a set number of electrons. The first electron shell can hold up to 2 electrons. The second electron shell can hold up to 8 electrons. The third shell can initially hold 8 electrons, though later on it can hold up to 10 more, giving us the transition elements. So in the case of a hydrogen atom, its 1 electron occupies the first electron shell. For a helium atom, both of its 2 electrons also occupy the first electron shell. For a lithium atom, 2 of its 3 electrons occupy the first electron shell, while the third electron occupies the second shell. For a beryllium atom, 2 electrons occupy the first electron shell, and the remaining 2 occupy the second shell. In written form, these configurations can be expressed as follows. The values in these expressions represent the number of electrons in each of their corresponding electron shells. Now for an exercise. See if you can draw the electron configuration diagrams for the following elements. Grab a pencil and a piece of paper, pause the video, and resume when you're ready. Now let's compare to what you've drawn. Now notice that the atoms for all elements in the second period have 2 electron shells. You will also notice that the number of valence electrons, that is, the electrons occupying the outermost shell, correspond to the group number. For instance, let us have a look at nitrogen. Nitrogen is in group 5 and has 5 valence electrons. Oxygen is in group 6 and has 6 valence electrons. So moving from left to right in the periodic table, the number of electrons in valence shells increases by 1 electron. Are you ready for the next exercise? Let's try drawing the electron configuration diagrams for all the elements in the third period. Grab that pencil and paper again, pause the video and resume when you're ready. You will see the same trend for the group number and the number of valence electrons as you did in the elements for the second period. Notice that the electrons for all elements in the third period occupy 3 electron shells. For potassium and calcium, their respective valence electrons occupy the 4th electron shell. In summary, we've seen that the number of electron shells corresponds to an element's period number, and the number of valence electrons corresponds to an element's group number. After this, things get more complicated. Remember how at the beginning of the video we saw that actually there can be 18 electrons in the third shell, but this is for another lesson.